Everyone, our group will be present a case study on a textile wastewater treatment plant in Malaysia. The textile industry is important for the economy, but it also creates a lot of wastewater with harmful substances like dye, metals, and chemicals. This wastewater is hard to treat because of its strong odor, high pollution, and changing pH. If not treated well, it can damage the environment. Our case study looks at how the plant works, the treatment method used, and how it can be improved to meet environmental standards.
Hi, my name is Sarah. So today I'm going to talk about the textile effluent treatment plant. So it started at the inlet, going to another section, to a tank and machines like a cleaning, chemical treatments, equalization. So that means the clean water either reused or released. So this part that's straight is hopefully it works more smoothly. So the process flow is started from the factory that release dirty water that come off the screen for the big waste. So the dirty water going down to the tanks to balance the flow, and then the chemical is added to clean it up. After that, a biological process is added, a process to clean it up and destroy the harmful stuff, and then it is filtered. After that, the water is either be released or being reused.
Effluent and effluent properties in textile wastewater. Effluent is the wastewater before the treatment, and effluent is wastewater discharge after the treatment plant. As shown in the table, pH, suspended solid, DOD, COD, color, and toxicity gets lower after treatment to comply with regulations.
Move to the importance of compliance with wastewater discharge standards in the textile industry. In Malaysia, effluent discharge is regulated under the Environmental Quality Industrial Effluent Regulation 2009 and enforced through the Environmental Quality Act 1974. Textile wastewater contains a high concentration of pollutants such as dyes, heavy metals, and chemical oxygen demand. To reduce the environmental harm, the law sets maximum allowable COD levels, which is 80 mg per liter for standard A reverse and 250 mg per liter for standard B reverse, as outlined in the 7th schedule. Complying with these limits is crucial to ensure that industrial effluents do not degrade water quality or harm aquatic life.
Conclusion: significant level of contamination are present in the textile wastewater sample, as evidenced by measurement of pH, color, COD, DOD, and suspended particles. They are greater than allowed environmental limits. The necessity of appropriate treatment before to discharge is highlighted by the high concentration of organic chemicals and pigments. Wastewater requires effective treatment, for example, sedimentation, biological infiltration, to prevent environmental harm. Compliance with standard is vital to protect ecosystem and public.